Hey everyone, it's Trevor Makes, and in this video I'm going to be taking a look at this untested Commodore 64 that I picked up at a garage sale a while back. This Commodore has changed hands a few times, and it's obviously had some internal modifications done to it, so I have no idea what parts of it will and won't work. And if you want to find out, you'll have to stay tuned while I get this computer restored back to working condition.
Are you keeping up with the Commodore? 'Cause the Commodore is keeping up with you. Are you keeping up with the Commodore? 'Cause the Commodore is keeping up with you.
Now, starting with a look at the outside of the case, the first thing I noticed is this interesting dust cover on here, which is actually removable. And there's a whole bunch of tacky stickers on it that I'll go ahead and remove, as well as kind of just some grime and dirt on the outside of the case, which I'll be able to get cleaned up. Actually, the plastic looks pretty good. It's a lot less yellowed than my other Commodore 64, so that's fine. Looking a little further, I already pointed out this reset switch that's been added on here. That basically tells me that somebody else has already been in here, opening up the case, soldering stuff inside. I also noticed this comes with the older 5-pin video connector, which means it does not have the chroma signal, so you cannot get S-video out from this. And also means it's one of the earlier board revisions, which is corroborated with the 5-digit serial number, which I think puts this at maybe 1982 or 1983. It's going to be one of the earlier models, but we'll find out when we get this opened up. And the last thing I've noticed looking at the outside of the case, unfortunately, it seems to be a little loose back here, which I think means that one or two of the plastic tabs on the back hinge here have broken off. Not too big of a deal, but maybe I'll be able to fix this up. I don't know if the hinge is still inside the case or not. We'll see. But before I open this up, I think I'm just going to go ahead and plug in the power, plug in the video, boot it up, and see what we get. Okay. Got the line on the side. Oh, wow, look at that. It actually just boots right up. The RAM looks okay. I was not expecting that. Let's see if we can... Okay. So only some of the keyboard keys appear to be working. That is probably the same problem that I had with my other Commodore. Just the keyboard contacts are old and oxidized. I'll just need to take the keyboard apart, clean those out with an eraser. That should be an easy fix, and I actually can just test that by swapping out the cleaned keyboard from my other Commodore 64. Can also just see here the reset switch appears to work. That's cool. This might actually end up being pretty straightforward, but let's go ahead and put in a game and see what kind of sound and video output we get. Okay, so I'll plug in my joystick into port 2 and power it up. That doesn't look so good. What? So that output's not looking so good. Oh, but that looks fine. Wonder why that first... Oh, you know what? That might be the... Okay, get the guard to chase me. Looks like we are getting sound output there. So that's very encouraging. Everything seems to be working. I've got a good VIC, I've got a good SID, I've got a good PLA. All the DRAM seems to be working. All the ROMs seem to be working. So I think possibly all I'm going to need to do is just get the keyboard cleaned up and clean up the case and everything. And I should have two working Commodore 64s. Okay, so let's go ahead and open up the case. Flip it over, and first we have to remove these 3 Phillips head screws. Okay. Okay, now we carefully open from the front hinge towards the back. Undo the LED. Keyboard connector was on there pretty firmly. Now, because this reset switch is soldered directly to the board, if I want to take the top piece off, I think I might want to put a little connector on here so it's easier to take this off without needing to unscrew it from the case. So you can see here's the plastic tab here that's broken off. This one is missing completely, and this one is a little loose. Here you can see what they're supposed to look like. These ones are intact, these ones are intact, and these ones are broken. But the good news is that looks like it should be pretty easy to fix up. This one I can just glue, and then I'll look for a little piece that'll fit there. So I'll set the keyboard aside for the moment. Let's take a look at what's going on in the board here. So it's looking kind of grungy inside. There's a bunch of just dirt and crap in here. Yeah, there's just all kinds of lint and grunge and stuff in there. So I'll have to get that cleaned out. And obviously this is the old board revision with the long and flat case around the VIC. You can see it's a 1982. What kind of codes do we have on these chips here? 82s, 82s, 82s. Interesting. This CIA is an 86, so this must have been a replacement. So 6581, that's the SID. This must be the PLA right here under this sticker. And I'll get that sticker off and see what we've got under there. So the PLA reveals itself to be a Signetics 82S100. This was the very first version of the PLA using a true programmable logic chip. Taking a look at the ROMs, we see that we have revision 1 of the kernel. I would like to upgrade that to a later revision, or maybe put a kernel switcher in here. Unfortunately, the character ROM is in a socket, but the kernel is not. So if I want to make any modifications there, I'll have to desolder that from the board. I already know there's nothing that needs to be fixed, so this one is already loose. Is this one stripped? Something funny is going on with that screw. Oh yeah, you can see. There it is. So I can try and fix that later. That should be easy with glue. So it looks like the RF shield on here was removed in the past, but was reattached. It's snipped here, but I can see where it's been desoldered and resoldered. So I'm going to have to take that off yet again. But I think it's pretty obvious that this has been removed before because there's at least this replaced CIA right here. Okay, let's go ahead and take a look at the VIC here. There we go. Clean the thermal compound off of here. Okay, so here's a close-up of our ceramic VIC-2, a 6567 R56A. This is one of the first revisions. Unfortunately, we're probably not going to get very good video output from this VIC, but we'll see what we can do to clean up the signal. I'm going to go ahead and get the board cleaned up a little bit first, and maybe work on the keyboard and the case, and I'll take a look at desoldering this a little later. So I had a better idea for testing out the keyboard matrix, which is to make 2 of these little adapters like this. What this will do is I'll plug one of these into each side of the keyboard matrix, which is 8 consecutive pins on the keyboard connector. And this will tie all of the pins of each side of the keyboard matrix together, and I'll be able to hook up my resistance meter to each side, one to this one and one to the other one that I'm going to make. And that will let me measure the resistance of any single key press. So I'll go ahead and solder these two together really quick. Not the best soldering, but it should be functional. So now if we take the keyboard connector, we can see that there's one pin filled in. What we want to do is we want to take the furthest 8 pins away from that, plug in the first connector there, and then we take the second connector and we're going to plug it into the 8 pins immediately adjacent to that. It's not quite plugging in all the way here, but it's still making contact, so it should be fine. For the resistance measurement, I'm going to try out this KM602 Smart Digital Multimeter that was sent to me by Kaiweets. Power it on. It starts up in automatic mode, but I'm going to go ahead and set it to resistance. And so the display shows me which of the 2 ports on the side I need to plug my probes into, so I'll go ahead and do that. Because resistance measurements don't have a polarity, it doesn't matter which probe goes to which. And so I'll go ahead and plug these clips into the adapter that I made, like so. Set that down. Go ahead and put that there. And so I know from my testing before that the Z key worked. So I measure about 150 ohms, that's not too bad. The T key was also working, but this one's a little high, about 1,000 ohms. So here the 1 key is reading, it's kind of all over the place, but it's reading above 10 kilo ohms. 2 keys reading about 30 kilo ohms. 3 keys reading about 5-6 kilo ohms. These are way too high for the CIA to register them as key presses. So it's clearly what I thought it is. The keyboard contacts are just going to need to be cleaned out because we really want to see less than like 100 ohms on a key press. Now there's one key that's not part of the keyboard matrix, the restore key. And so to test the restore key, we want to test the resistance across the 2 pins that are around the filled in pin. That's pin 1 and pin 3. So I'll just plug in my little adapters sideways. And like that. Okay, now I can test the restore key. And yeah, getting between 10 and 30 kilo ohms when we press that key down. That's way too high. CIA is not going to register that. So the next step will be taking this keyboard apart and cleaning out all of the keyboard contacts. So that's going to require taking this piece of tape off here to get access to all these little screws. And they're tiny Phillips head screws, so you'll need a smaller screwdriver for those. Now, aside from the screws, there's one other thing which needs to be done, which is to desolder the wires going to the shift lock key. Okay, so what I'm going to do is just touch my soldering iron to the solder to get it melted, and then pull the wire right out. And just do the same thing in reverse when we put the keyboard back together. No big deal. Now the PCB is free to come off. And that reveals the contacts that we need to clean up. And I can already tell it's not just oxidation, it's actually kind of dirty and dusty. That picks up pretty well on the camera actually, especially like over here. Okay, I got the dust off, so now I'll go ahead and wipe it down with isopropyl alcohol. It's already looking a whole lot cleaner, but let's see if there's any pads that have really obvious corrosion on them that I can show you. So if you look really close, you can kind of see some little imprints from where the keyboard plunger used to press down. And that's what we want to clean up with the eraser. So here's one I haven't cleaned off. You can see the imprints there. And then here's the ones that I did clean off. They no longer have that little imprint on them. And so that's what we want to do to clean up every single one of these contacts. Okay, so after that, all of the contacts are looking pretty shiny and clean. So next we move on to cleaning up the plungers. Last time I pulled all of the keycaps off so that I could take the plungers out, But this time, I think I'm just gonna leave the plungers in since the keys themselves weren't too dirty. And I'll just give each plunger a light scrub with this eraser. Okay, and there we go. So before screwing the keyboard back together, I just want to give it a quick test with the meter to make sure the keys are looking good. Here's the space bar. Now it's reading about 60 ohms. Now, just to be thorough, before putting everything back together, I want to test the shift lock key since I'd had a problem with that key switch on my other Commodore. So it should be very low resistance or close to closed. Here it's reading about 6 ohms, but if I just touch the key slightly, now it's an open circuit. In both cases, the key is pressed down. It's in the locked position, but just the slightest little movement changes between an open circuit and a closed circuit. So I'll just have to take this key switch apart and bend the contacts so that it's always staying closed when it's pressed down. Now for this one, we don't actually need to take the keycap off because the shift lock key actually pushes right out from the bottom. So we can take it off like so. So these shift lock keys are kind of like the mechanical keyboard switches that you see in modern keyboards, except in this case, these are locking type key mechanisms where they stay locked down when you press them. But the way that you get these open is with these little gray tabs here. Just lift that up. Lift it up on the opposite side. You can slide this little mechanism out. So the way this switch works, it's kind of hard to see, but where these dimples are on this little spring contact right here, these make contact with another little piece of metal that's right under here. And so when the key is in the locked position, this spring gets pushed down like that and closes the circuit right where those little dimples are. So what I'm going to do is bend this part out. So hopefully when it's locked down, it's going to push this down just a little bit harder to hopefully make a better contact right there. Okay, now I'm going to slide the whole thing back together. Hook the meter up again. Okay, so now wherever I wiggle the key to, it's still reading under 100 ohms, which is good. And when I depress the switch, it's making a little bit of contact, but the contact that it is making is up in the tens of mega ohms, which shouldn't be a problem. It seems to be working much more reliably now, so I'll go ahead and put that back into the keyboard. First, I'll go ahead and resolder the wires for the shift lock key. And now I can reinsert all of these screws. Okay, there we go. Okay, let's hook this meter up one last time. So some of the keys are a little higher than I'd like, but nothing is too bad. I think all of the keys now should be working just fine when I plug the keyboard back in. And just to be complete, we can check pins 1 and 3 of the keyboard connector again with the restore key. And there we go, restore key looks good. So I would say this whole keyboard is now going to be functional again. But because I want to clean all these stickers off, I think what I'm going to do is go ahead and remove the keyboard from the top of the case. Okay, so the keyboard itself actually looks pretty clean, probably because of the dust cover that it had on it. The restore and return keys look a little grungy, so I might clean those off a bit, but I'm mainly going to be focused on getting these stickers off and cleaning up some of the dirt and scuffs on here. Okay, so I'll start by taking these stickers off. So the stickers are removed, but we still have quite a bit of sticky residue on here. So I'm going to go ahead and use a bit of this citrus oil based glue remover. Okay, now I'm going to go ahead and go over the case a little bit with some plain water. And now I'll do one last pass over the outside of the case with some rubbing alcohol, just to remove all the remaining traces of the oil and to help it dry off a little quicker. Okay, the case is looking nice, so I'm going to go ahead and reattach the keyboard here. And there we have the top of the case reassembled and looking brand new. I'm really happy with this plastic. It doesn't really look yellowed at all. And I really like these gray keycaps compared to the kind of yellowish, tannish ones that I have on my other Commodore. Okay, so now I'd like to go ahead and reconnect the keyboard. Oof, that connector is very stiff. I don't like that. Reconnect the video. Reconnect the power. And let's just check up on how everything's doing so far. Type in a quick program. There it goes. All right, now we have a conga line of rainbow Commodore balloons. My job here is done. So we've already made a whole lot of progress with this computer, but there's still a few more things that I'd like to look at. Like in particular, there's some easy mods for the video circuitry, improving the luminance and chrominance signals, getting the chrominance routed to one of the video pins so that we can get a proper S-video output. Also some things like improving the heat sinking on the voltage regulator, maybe looking at upgrading the kernel to a later revision, maybe putting in a kernel switcher so I can try out some other kernels. But this video has already gone on for a while, so I think I'm going to have to end it here and take another look at mods for this board revision in a follow-up video. Anyway, that'll do it for this video. Thank you very much for watching, and I'll see you next time.